If x and y are acute angles, that's important, first quadrant, sine x is a quarter and cos y is 3/4, determine sine of x plus y without calculating x or y. Well, sine of x plus y is going to involve both cos n sine of x and cos n sine of y. So we're going to have to work out what cos x is and sine y. We know they're in the first quadrant, and we're just going to use Pythagorean identities. So cos squared x is 1 minus sine squared x, which is 1 minus 1/16, which is 15 on 16, which means cos x, now normally it would be plus or minus, but we know it's, in this case, in the first quadrant. So it's root 15 on 4 in first quadrant. Whoops, I can't write quadrant. Likewise, we need to find sine y. Well, sine squared y is 1 minus cos squared y, which is 1 minus, not 3/4, 9 on 16. Well, that is, 16 take 9 is 7/16. So sine y is root 7 on 4. Again, because I know it's in the first quadrant. Otherwise, I would have to account for negative values here. But I know they're in the first quadrant, so they must be positives. Okay, now I know enough to work out sine x plus y. Sine x plus y is sine x cos y plus sine, how do I write this rule? Cos. I mean, you can write it that way, but I'll just confuse myself as well as you. Cos x sine y. Put in what I know. Can I move that so you can see both? Sine x is 1/4, cos y 3/4, cos x root 15 on 4, sine y root 7 on 4. Then simplify. That's 3/16 plus root 15 times root 7. And that's 3 times 5. That is not going to be simple. 15 times 6 is 90. So 15 times 7 is 105 over 16. This won't simplify because it's 3 times 5 times 7 and they're all prime. 3 plus root 105 over 16.